actuary dude over here looking at another exam question. Okay, so a forward contract with a settlement date at time t is issued based on an underlying asset with a current market price of B. In the notes it's normally, I think it's S0. The annualized risk-free force of interest applying over the term of the forward contract is delta, and the underlying asset pays no income. That's easy. Show that the theoretical forward price is given by this equation, assuming no arbitrage. Okay, cool. So let's look at that. So we're starting over here, and we could buy a stock or whatever we want to buy, something that's worth the value of B. And at time t, we also have the option. You can do one of two things over here. We can pay B now and own the stock, and we'll own it for that whole year, or we could do something else. We could say, you know what, I don't really want to own it now. I'll own it at this point in time, and at that point in time I'll pay K. So it's basically saying, well, how do we get to this equation? Well, we can do this. You can pay, well, this is K in the future, so let's work out what that's going to be at our time now. So we can choose to pay B, or we could be saying that we're going to be paying K in the present value of K. So how much should we save up to be able to afford our stock in the future? Is it going to be cheaper or not? Well, if we assume no arbitrage, then we're just going to be discounting it back this amount. So we're going to be discounting back delta times this amount over here, and they're going to be equal because you're not going to be able to make a profit by getting one or the other. And so if you do that, then let's just reverse this whole thing, and we'll find out that K is equal to that is B to the positive delta T. And that's how you get to that. So you can just write down however you want. We can either buy B now or we can buy K later, but the amount we would need to pay for that K so happens to be the value of B. Alright, so let's look at the next part with some numbers. So an asset has a current market price of 200 pence, and it's going to pay an income of 10 pence in 3 months' time. So what is the forward price of the contract, which is going to be settled in exactly 6 months? So if we're looking over here, we have 6 months, we have 3 months, 0 months. So at time now it's worth 200. We're going to be receiving an extra 10, and in 6 months we can pay some amount K, which we would have agreed on at this point. So what is that? Assuming a risk-free rate of interest, and which is 8% convertible quarterly. So that is I to the 4. Alright, well, let's just work this one out. Basically, once we find out what I is going to be equal to, which is 1.02 to the power of 4 minus 1, we're then just going to be saying that K being discounted back, so K times V to the half a year, 6 out of 12, is equal to 200 minus 10 being discounted back a quarter of the year. So let's just keep things with fractions. Quarter of the year. And that's really it. And then we're just going to get K by itself. So let's find out, because we know how to do that. Except this is using a force of interest, whereas over here we're just using a regular rate of interest, an effective rate of interest. So let's calculate this. Okay. So let's just first find out what I was equal to, and that was 1.02 to the power of 4 minus 1, which that is our I. So that's I. Let's find out what V is equal to, which is 1 divided by 1 plus I over there. And now let's just solve this bit and find out what K is. So that is equal to 200 minus 10 times our V to the power of a quarter. And then we just have to multiply it now. We've got to accumulate it for half a year, which is that times 1 plus our interest rate to the power of a half, which is, there we go, 197.88, which is in pence. So 197.88 pence, which should really just be £1.98, to be perfectly honest. Okay, so that's the answer, and ask if you have any questions. Thanks for watching.